Yeah, good thing
Okay, we're on there now. We just figured out that question 3 is true. And now we're on a charity.
All right. What is the probability that a random selected person in the United States has type O blood? Round to the nearest decimal place.
I got 0.45.
Put my calculator into it.
You okay?
Yes.
Okay. What is going on?
Sorry, I for some reason I've got a Christmas ornament on my
Oh.
so it like makes noise every time it gets touched.
So what is the probability of the person? So yeah.
So how did you do that math then?
Well, you just look at the table.
Yeah.
There's literally no math to it.
Oh,
that wasn't
okay.
supposed to be like rude or sorry.
Yeah.
Sometimes I come off that way.
Oh.
No, you're fine.
Whatever. Yeah. This quiz is mainly like looking at the tables and like.
Yeah.
It's 45%.
Yeah, but you put it as a probability, so it's 0.45.
Yeah.
Oh, okay.
That a random person will not have.
So that's just 1 minus 0.45.
It's 0.55.
0.55. That's what I got. I went the more roundabout way, but that's what I got.
Added them all up at the other end.
That's a little hard.
Yeah. All right, I can read the next one.
Sounds good.
Carolyn Wills and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangled, one of the dogs, demonstrates the identifications of a specimen. 7 bowels containing urine were lined up in random order. Sorry, tricky there. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Question 6. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Render your answer to 3 decimal points. So it's just 1 divided by 6.
1 divided by 7.
Listen, there's 6 of the samples were patients who did. Oh, 1 of the samples.
7, yeah. There's
okay, 1 divided by 7. Yeah, sorry, that's confusing because it says 6 of the samples were
0.142.
Yep, I got 0.143. I think I rounded it up though.
Yeah. 2 decimal points, so yeah, just 0.14, right?
It says 3 decimal places.
So yeah, you would round up that last
0.43. Okay.
0.43. Okay.
Sweet.
Okay.
Alexia, is your screen working? Because mine keeps showing that yours is black.
Yeah. In mine too.
I don't know why, but I think that's the last of our words.
Yeah.
Right now, so.
Yeah. I'll take the next one.
Sorry.
Okay, do it, dude.
So it says, number 7, it says, in a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statement is most appropriate? This provides strong evidence the dogs can detect bladder cancer. This is little evidence that dogs can detect bladder cancer, sorry. I kind of want to say, like, I don't know, this is just my thinking, that I just took the 22 they got right and divided by the 54, and I got 0.407. So, like, 40% of the time, or 41% of the time they could detect it. So yeah. I kind of want to lean with there's little evidence that dog, or I guess B. That's what I think.
So before we had like the percentage or the chance of them getting, like guessing it with, and the 1 in 7 was 0.143. So if we like followed that stat 54 times, we should still only have, around 0.143. So the fact that it's like 0.4 something, I think it lean, but yeah, it's hard because it's not like it's 90 or 80% or.
I said this provides strong evidence that dogs can detect bladder cancer, because even if you, with the amount of evidence or like the probability that they'll take it, so if you times 54 by that probability, they should only detect it around 7 or 8 times if there's no, if they can't detect it.
Yeah, it's like less than 20 is like, or something like that, isn't it? Like,
Yeah.
because
So,
even like the polio shots, only like the first round that they did, it was only like 37% saw a difference, and that was like groundbreaking.
yeah.
Oh.
So I'll put that. I'll submit it and then we'll see. But I think that's it. Yeah, I put A.
Okay.
Okay. M&Ms are small chocolate candies. The M&M website previously indicated in the United States, this distribution of colors in the bag of M&Ms is given in the following table. If you reach your bag of M&Ms, what is the probability of drawing your red colored candy? Okay, so it's 0.13.
All right. What is the probability that randomly selected a green candy?
I'm adding them all up right now.
I got 0.16.
Yeah, me too.
Yeah.
Yeah, 0.16 is what I got too.
Okay. Sweet.
Randomly selecting a candy that's not green, you're just going to use the other percentage, just 0.84.
Yep. Okay. I don't know if we're going in an order right now, are we?
What?
Are we going?
I've
Can
got.
I go? Should I just go?
Go for it.
Okay. The ACT scores of students admitted to a medium-sized public university in the western United States were taken from a CAPEX.com. The following summary statistics were calculated. Half of the observations are less than or equal to what number? So that's the median, right? So 24.
Yeah.
Yeah.
Okay.
Based on the information on the table above, the top 25% of students scored above what number? So that's the, is that the
27. That's a Q3.
Q3.
Yeah.
the third row, right?
Q1 is 25%, median's 50%, Q3 is the 75%, so
Like you
27.
It was the maximum of, or the third quartile. I got confused.
You're good.
Okay, 27. Can you guys hear me okay? Sorry, my headphones died.
Oh
Yeah,
yeah, you can hear you great.
Yeah, I can hear you fine.
Okay, number 13.
Which of the following statements is not one of the 3 rules of probability? The probability that an outcome will not occur is 1 minus the probability that it will occur. Okay. A probability is a number between 0 and 1. If the probability is high, then the probability is positive. If the probability is low, then the probability is negative. The sum of all probabilities in any the sum of probabilities in any probability is 1.
It's if it's high, then it's positive.
Yeah.
Yeah, that's
Yeah.
Okay,
That's
I'll submit right now.
okay.
100.
Dope.
I got 100.
Sweet.
I got 50.
Wait,
No.
no, you didn't.
100.
Yeah, I got 100.
Okay, sweet. Sounds good. Okay, and everyone's ready to meet on Thursday too?
Yep.
Yes.
Yep.
Okay.
Hopefully it won't take this long next time.
Yeah, seriously.
But I mean, this meeting was only 15 minutes or even that, 12 minutes.
Yeah, we knocked it out.
Yeah. When it gets further along, like in the class, the group meetings will have like 30 questions, just as a heads up.
Seriously?
Yeah, and they get like way harder when you start getting into like p-values and p-hat and stuff like that. So like your meetings can take like 2 hours.
Holy crap.
Wow.
Yeah, just as
Okay, sweet. Well,
All right, Chris.
awesome. So on Thursday, I'll just try to send a Google invite the same way I did just like in that little group message thing since that worked best. Okay,
Yeah.
perfect. Sounds good.
All right.
Okay. See you
All right,
guys.
see you guys.
Thursday.
Bye.
Okay, bye.
Bye.